Hello and welcome to today's topic. Today we'll be discussing about how the circuit breaker pattern is effective in WSO2 and how it has been implemented. So WSO2's Enterprise Integrator provides the capability to set up services with the protection provided by the circuit breaker pattern. Um, we'll quickly look at what a circuit breaker is. Now, from the electrical point of view, or an electrical network or an electrical circuit point of view, we know what an circuit breaker is. It's meant to actually protect the downstream systems from any kind of damages in case there's an overload in the electric circuit. Now, from a software practice, this pattern has been actually emulated, and what we see is a similar kind of process. So here you can see there are two services, service 1 and service 2. If at any point in time service 1 starts to actually be flooded and service 1 starts to slow down, then the circuit would actually break and no more request would actually be sent to the service. On the other hand, as long as service 2 is functioning without any slowness or working in an expected manner, the circuit would still stay closed and more traffic would continue to go on. So I'm not going to explain how the circuit breaker pattern works. There are lots of articles, there are lots of frameworks that actually provide enough documentation around it. This video is only going to be around WSO2 and how it actually functions and what are the bells and whistles that are there to actually control the circuit breaker. So we'll quickly get into a demo. Now, before we go into the demo, there is some groundwork that I want to actually explain because this would be relevant to what you actually see. So we start off with a native service. Now for this demo, I have actually set up a service on my laptop and it's actually running on SOAP UI as a mock service. I have set up the execution time of the native service to take around 20 seconds. Then you have the WSO2 Enterprise Integrator, which actually has a proxy service that connects to the native service. Now, what a proxy service is and how a proxy service works, there are many tutorials. One of my colleagues actually has a good tutorial setup. I will provide the details to his videos. You can actually go through them and there are step-by-step instructions on how to start with WSO2 Enterprise Integrator and how to actually build proxy services. It will be provided at the bottom of the video. Now you have a proxy service in the front of WSO2 that actually proxies the request to the native service. All of this is actually the demo setup. And from here we actually take it. So a request comes into the proxy service, which is then handed off to WSO2. WSO2 in turn communicates with the native service and the native service responds back. Now, as you see, I have consciously chosen the timeout between WSO2 and the native service as 5 seconds. But in practical use cases, the native service's execution time would be random and a certain SLA would be there. So if the native service SLA were, let's say 10 seconds, then ideally your connection timeout should be greater than the execution time of the native service. But in order to demonstrate that the circuit actually breaks and is re-established, I've kept the time frame as short as possible. Now let's get into the steps of executing it. So as you can see, I have a couple of applications opened. So right in the beginning, you have Enterprise Integration Studio. This is the developer tool from WSO2. This actually helps you in building services. So I have built a service over here and it's a pretty straightforward service. It uses a particular mediator, send mediator to actually make a call to a native service. The native service is mentioned over here. This is what I had actually explained in the demo setup. This is the native service. It makes a call and it comes as a response back to the caller. You can see a different perspective of this in the source view, where you have details about the actual endpoint. So you could either look at it from here, or you could come back on the design view, click on the address endpoint, and in the address endpoint, you would see actually what's happening. So you see that you suspend the endpoint after attempting 3 times. And there are more other configurations, but it's easier to actually understand it from the XML perspective. So as you can see over here, I've set the timeout to the endpoint, hello site 1 to 5 seconds or 5000 milliseconds. And if it actually times out before, or let's say after 5 seconds, or if it actually takes more than 5 seconds, it would set it to timeout. Now, setting an endpoint to timeout is repeated 3 times. And on the 4th attempt, it actually suspends the endpoint. So on the 4th attempt, after it suspends the endpoint, this would actually then continue. On the 5th attempt, if it still takes time, it would actually be suspended for 20 seconds. The next time it will be suspended for 40 seconds. And next time it's suspended for 60 seconds, up to a maximum of 60 seconds. So this is a basic setup of a circuit breaker. There are more advanced capabilities. All of this can be actually configured over here as well, but this is actually a simplistic view of it. So you actually call off an endpoint. This is our mock endpoint, and these are the configurations available. So to summarize, the endpoint timeout is set to 5 seconds, and on suspension it would be suspended for 20 seconds, and you then actually have a progression factor of 2. So here you can see that my enterprise integrator is actually running a couple of executions before. I'll go to SOAP UI and show each of the components. So this is actually the mock service running. I have a mock over here. I have set a timeout now for, let's say, 100 milliseconds. And this is the endpoint of the mock. So as you can see over here, if I execute request to the mock endpoint, you can see in 100 milliseconds, the response comes back. If I were to increase this to 1000 milliseconds, you see over 100 milliseconds, on execution, it would be 1 second. And subsequent executions would all be like in the order of 1 second. So this gives me the freedom to actually choose or demonstrate the circuit breaker pattern with convenience. So if you remember, we had set up the endpoint timeout to 5 seconds, and now I'm going to set a value for the actual native service. So before we get into that, I'll just demonstrate the service from WSO2. So this is the WSO2 endpoint running on port 8280. So if you see, the response is nothing, hello world mock, and here also you would actually get a hello world mock. So this proxy service makes a call to the native service, which actually returns back the response. So now I've set the timeout to 100 milliseconds, let's say 100 milliseconds, to just demonstrate that this whole thing is working as expected. So I do one execution. It goes to native service, and you see the request reached over here and the response came back, and the same would have been listed out over here. So at 5:35 a request has come in, and I can keep firing a couple of calls. Okay, so actually the screen gets stuck because of me blocking the logging. It's a console logger, so it actually blocks the API. So if you see, it keeps on executing as many number of calls without any problems. And it takes around 100 milliseconds to execute. Now let's say I increase this to 1000 milliseconds, that's like 1 second. And then I execute the native service. So as expected, it responds in 1 second, a little more than 1 second. So this is our basic setup. Now our expectation and what we're going to demonstrate is that we'll make the native service take longer than 5 seconds. And then show that the call to the mock service actually times out, and after 3 repeated timeouts, it actually suspends the endpoint. Any other calls after the circuit is broken, it's short circuited and no more requests go to the backend service. So the way to validate that no more requests are going to backend service is by noticing the traffic that comes here. So I'm going to actually keep it turned off. I'm going to increase the timeout of the backend to 20 seconds. So if you remember, the timeout to the native service is 5 seconds. The actual execution time of the service, the native service, is 20 seconds. So let's start. So you can see over here, the last request was at 5:35. Okay. So we've executed the first call. So a call should have gone at 5:36 to the endpoint. And as we wait, we should start seeing interesting messages coming up over here. So it says the endpoint is marked timed out, and there are 2 more attempts because it timed out after 5 seconds and there was no response came back in 5 seconds. So okay, so let's break the call. So you see there's a call came over here, but it took 20 seconds to respond. Let's break the call. Let's make the second one. So now we made a second request. It's gone. The request has been sent out at 5:37. Again, it's been marked for timeout and you have 1 more attempt. So it's actually informing you have 1 more attempt to make the call. And the request is still to be executed. It's going to take 20 seconds. So it's executed now. So I break the call again and I try the third time. So as you can see, now we can wait for the third attempt to come here. That should be at, let's see, 5:37:53. Yeah, so the third one has gone out and it says there are 0 more times after which the endpoint will be suspended. So we're going to break it off and we'll make the fourth attempt. Now, after the fourth attempt, we should actually see that the endpoint is actually suspended. So in all these executions, the endpoint is only set to a timeout. But now very soon, we'll start to see that the endpoint is going to be marked for suspension. Just give it a minute. So it says the endpoint has been marked for suspension, not timeout anymore. So it's actually now in a suspension mode and it's suspended for 10 seconds. So let's give it a try. It was a bit late. I think it had already elapsed 10 seconds. Yeah, okay, it's now in timeout. It's in suspension mode. So you see, now no matter what I do, it is not going to accept a request. And you'll not see any logs coming to the backend. So despite how many attempts you fire, for the next 10 seconds, it's actually suspended. Now after 10 seconds, the next request comes in and it's going to try to do a verification if the endpoint is going to respond. And the cycle continues. Now it has been marked for suspension, but the duration has been increased from 20 seconds to 40 seconds. I think it had already increased the second round to 20 seconds and now it's increased to 40 seconds. Now you'll have to wait actually 40 seconds for the endpoint to become active. So as you can see, no matter how many requests I'm sending, the native service is receiving none. So basically now the backend gets a breathing room to actually recuperate and come back to normal operation. Until then, WSO2 Enterprise Integrator keeps the downstream systems healthy and it gives it more time. So as we see the logs, it says that the endpoint is suspended and it should be available next at 15:40:12. So I think the endpoint should be back. I think it's been 40 seconds. To try. It says next retry after 21:17:40 and 12 seconds. Yeah, so it's past that. So yeah, so at this point we should see 1 more request coming into the backend. Let's give it a couple of seconds. Yeah, so as you can see, the next request has come in, but again, because it has timed out, it should start to mark it for suspension. See, it's actually marked for suspension, and now it has increased it by 20 seconds, so it's now 60 seconds actually, and it's going to be available only at 17:42:02. So until then, no matter how many times you fire the request, the backend is going to actually be protected, and no requests are going to be sent over here. So as you can see over here, this is how WSO2 switches on the circuit breaker and puts it back. Now to see how it actually goes back, we know that at 17:42 it's supposed to actually go back. So by that time, let's actually send or keep the backend native service to be a couple of milliseconds, so to simulate that the native service is healthy now. I think it's now 42, 17:42. Let's fire a request. It could be that I've blocked the, yeah. So sorry. Now it's actually healthy, and as you can see, the circuit breaker is closed again. Circuit is closed, and traffic starts to flow naturally. So what I demonstrated so far is the capability to trigger the circuit breaker and to put it back. And as you can see, there are advanced capabilities over here, such as suspend on what error code. It's not just a timeout, or there are different error codes that you can suspend on. You can do an progression factor, and it's not going to be just a incremental progression, but you can have different capabilities. You can say how many times you want to retry before actually the endpoint gets suspended, and so on and so forth. So the purpose of this video is actually to understand how the circuit breaker gets triggered and how it actually is closed when the native service comes back healthy. So I hope this has been explained and understood clear. If you have any questions, please let me know, and I should be able to clarify them. So as you see, this is now the circuit breaker in action. Now there is also another capability for a bulkhead pattern, but that is for another video and another detailed topic. But understanding the circuit breaker is necessary to be able to understand how the bulkhead pattern is actually enabled and how does that actually fit into the bigger picture. So to summarize, what we have seen is the circuit breaker pattern in action. And as you couldn't recollect, we have actually played around with the native service execution time to keep it higher than 5 seconds and lower than 5 seconds, and demonstrated how the circuit opens and closes based on the health of the native service. Thank you. And if there are any questions or clarification you would like to know, please send them in the comments and I'll be happy to answer them. Thank you very much.